Okay. In today's session, we are going to see what are the different advantage of HDFS. HDFS stands for basically self-distributed file system. Simply HDFS. Now we are looking into what are the different advantages and disadvantages. Uh, Whatever the disadvantage we have seen in our LFS and DFS system, that means local file system, distributed file system, all those problems are not here. That is comes as a advantage in HDFS file system. What is the first advantage? We can store huge amount of data, that is limited amount. Okay, we can store huge amount of data, that is unlimited amount. There is no specific amount. Okay, we can store different types of data. Structure, semi-structure, structured as well. Next one is can achieve both distributed and parallel processing. Then next there is good backup mechanism available in HDFS. Means replication. Basically, in old traditional technology, you are using one term is called backup mechanism or failover mechanism. That is, we will get good backup mechanism HDFS. How that is we are going to see in coming session. Okay. And any other? They are all the major advantages. Okay. So let me take a help of one diagram. Basically, every typical Hadoop cluster we have core component. One is DFS, another one is map radius. So in HDFS, basically the file system not only gives us so many advantages, but also allow us to store different types of data, allow us to perform distributed and parallel processing. Okay, I have another notes also. Okay. These are the different notes, and this is nothing but your, let's say this one is node 1 is located in Bangalore. Let's say another node S2 located in Delhi. Another node S3 located in Mumbai. Another node S4 located in which Chennai. And the main node which is located in, let's say 5. It is the master node, the name node, we can say. It is located in, let's say, Hyderabad. This is your master node. Which one? This one. This one is your master node. Okay. It's gone. It's gone. Sorry. Let me take another diagram. Okay. This is your master node. Let's say another node is here. Another node is here. Another node is here. Okay. These are all the every node. What I have told you earlier, one thing I have told you clearly, each and every node, there will be two major component must be running up and down. One is HDFS, one is MapReduce. As a part of, let's consider it is a HDFS system. So I am trying to make you understand one thing, how we are going to store huge amount of data. Basically, as there is lots of this, one is, let's say this is one TV. This is also one TV. This node also, let's say 700 GB. This one's, let's say TV. Okay. So each and every node, what happen in a typical HDFS Hadoop cluster, all the data will be maintained in the data node only. Slave node alternately known as the data node. Okay. In each and every data node, whatever you are looking here, this is a data node, this is a data node, this is another data node, this is also data node. Each and every data node contains the data only. It does not never ever contain any metadata. Okay. But you are looking at this area, this is the master node or name node we are saying, which is responsible to store only the metadata information, not the data. Okay, keep this point in mind. In mind. Okay, so this is the master node. Master node only responsible to keep the meta information, metadata about the data. What do you mean by metadata? Metadata is nothing but the data about data. Suppose I have a data set like 100, 300, 500, and suppose Ram, Syam, then Taylor, Smith, Scott. So 100, 200, what do you mean by 100, 200? This is 100, 200 are only rough figures. But what is the metadata for the 100, 200? Suppose let's say, let me tell you 100, 200, 300, 200, 500. Scott, Smith, Jones, Black, Turner. Okay. Let's say, what do you mean by this? This is, let's say, EMP ID. This is, let's say, this is the name. Then EMP ID and ename are the metadata information the all this data. So this information will be captured by HDFS file system, whereas this information will be captured by the data node only. But way we are going to store the data in a HDFS file system is very different from the other file system. That is, we are going to see in your application HDFS storage system. Hopefully, we are going to see those things tomorrow in the tomorrow sessions. Okay, next session. So first and foremost thing is we are going to store a huge. We can able to store huge amount. That means unlimited amount of data we can store. Okay. Now we are going to suppose this 1 TB is already filled. Another 1 TB is also filled. This 500 GB also already filled. 1 TB data is also already full. Okay, memory is full. So how can I store another? Suppose I am getting another day. I am getting another 500 GB of data. Then how can I process? Means that's nothing to do. The administrator will automatically they were going to add one more node. Okay. If this one also going to be full, then another node will be going to add. Likewise, they can able to add so many number of nodes. This is called your horizontal scalability. This is called horizontal scalability. At any point of time, if there is a requirement to extend the Hadoop cluster size, then we can add as many node as required. Okay. And this is how we are going to store huge amount of data or unlimited kind of data. Also, this gives us horizontal scalability, and such kind of things which is known as horizontal scalability. Okay, getting. So next is distributed processing. Suppose my data is stored I have a file. I am getting one file. Let's say getting one file, a.log file, which is saying, let's say 200 MB. Okay, these 200 MB is going to store in three different nodes. By default, Hadoop maintain replication factor, means duplicating the same copy in multiple node or multiple machine or multiple terminal or multiple slave node is known as replication. I can store 200 MB. Here also I can store. Here also I can store. Here I can also store. That is called backup mechanism also. Okay. Getting any doubt? What happened by default? Suppose in our local file system, what happened? I can able to store a single copy. If my machine, the machine that I am using, if it is gone or it is system failure is happened, then I will lose all my data set. There is no means of getting those records, those data. But in case of Hadoop cluster, what happened? As I am able to keep the same copy in multiple data node, this data node is getting down. Suppose if this data node is getting down, then I can able to recover another data node. I can, sorry, if this data node is getting down, then I can use other data node, because same copy is already available in another two nodes, right? But in a typical Hadoop cluster, in any other technology, it never ever gets such kind of backup mechanism except Hadoop system, and that is the facility of the HDFS file system. How we are going to perform the backup mechanism, how we are going to deal with the files size whenever we are getting a file, based upon the size, how we are going to divide this file into number of blocks and going to store or going to segregate or going to distribute in different slab node. That is a big session. We are going to see from the basic to advanced concept. Okay, everything we are going to see in depth of the how the file will be segregated. Everything we are going to see. Okay. By default, Hadoop maintain 3, but we can extend more than 3 also, or reduce 2 or 1 also, 1 copy. Okay. But 1 copy is only applicable in our pseudo distributed Hadoop cluster. Means the same machine, I have already installed my Hadoop. This is a single node, right? But in the same machine the machine that I am using to explain you all this concept, in the same machine my Hadoop also installed, right? So backup mechanism will be one only here. I'll use also 2 copy also, there is no use, right? Because it is a pseudo distributed Hadoop cluster. But if I have multiple machines, my Hadoop is getting installed for the multiple machines, then what happens? I can able to store the same copy of data in multiple device. If one is down, another one node is down. Suppose it is the Hyderabad node, another one is Bangalore node, another one is Delhi node. If Hyderabad node is getting down, then I can restart another node and start my processing. Such kind of backup mechanism is available in Hadoop, and there are some difference from Hadoop 1.x, 2.x, and 3.x as well in terms of backup. Okay, that we are going to see whenever we are going to basically with the Hadoop architectures. I'm going to explain you everything in Hadoop 1.x, 2.x, and 3.x. Not worry for that point of view. It is a advantage. Okay, what are the advantage and disadvantage? We are going to see in today's session, but in depth we are going to see. I am going to draw all the diagrams and everything that I am going to show you. how the file will be distributed, everything, how the configuration will be happen, in which file we are going to do the configuration settings, or we are going to do the configurations. Those things also I need to explain you. Okay, and hopefully you are going to see in the next session. So this is the way we can store huge amount of data. Whenever there is a demand to demand in huge number of data set received by the master node, to accommodate those amount of data, we can extend our cluster size by adding one or two nodes based upon the requirement. That is nothing but the horizontal scalability, and that is how we are going to store huge amount of data or unlimited kind of data. Okay. As per Hadoop is as per the big company Google, Yahoo. Yahoo is almost managing more than 4,000 nodes. Google is maintaining almost more than 7,000 or 8,000 in between some node. It is maintaining. Okay. So such kind of flexibility we have. Okay. That is the big advantage as compared to other file system. Distributed and parallel processing. As my data will be got stored in multiple nodes, I can without any dependency, I can process this data, this chunk of data, and this chunk of data as well. Because data node directly communicate with the master node only. There is no communication between one slave node to another slave node. They are only responsible to talk to the master node. Like which in a team, suppose you are working in a particular team and your manager assigned some work to you and you need to finish by individual without taking the that is assigned to you only. And it is your responsibility that you should finish done and deliver the task. No other person is responsible to complete the task and deliver to the gives the deliverables. The same way, Hyderabad node only responsible for the whatever the task it is assigned, it is going to complete, and then only it is going to deliver the inputs to the master node. Okay. So there are lots of things are there internally. What is job tracker, task tracker? Okay, secondary name node. All these things also comes into picture. FS image editors, everything we are going to see in the upcoming days, so that you can understand what is meant by distributed and parallel processing. Okay, this is how we are going to see what is backup mechanism. Separate session will be going to take. I will take separate session for the backup mechanism or replication. Hadoop we are saying is a replication, but in traditional traditional system we are going to say it is a backup mechanism or fault tolerant system. Backup or fault system. Apart from this, we can store different variety of data. HDFS is not only meant to store structure kind of data. We can store variety of data. That means in HDFS file system, data always stored in terms of files only. We never ever going to store data in terms of row and column. That is why we are able to store data of different types. Okay, this is all the advantage. Getting any other doubt? Now it is your turn. You can ask me if you have any doubt.
In backup mechanism,
Yes.
total a.log is equal to 200 MB. There is present data in a log file, 200 MB data.
Okay.
How you are sending the data from the or Hyderabad, any how we are taking that backup?
The same copy will be available in 3 different nodes. Okay. And how this particular 200 MB file size will be going to split into number of blocks and getting stored in multiple data node. That we are going to see in the backup mechanism in the different session.
Who will do that on that operation?
Everything this one taken care internally by the master node. Okay, whenever the client will going to gives a file record, send a file request. Okay, file request always received by the master node. So based upon the file size only, master node only going to decide. Okay, in which are the available nodes is there. Master node is, he knows. Okay, which nodes are available.
Okay.
On that basis, it is going to do the. It will going to adjust the data and store into respective blocks. Suppose let's say suppose suppose you are visiting a outstation and booked one. Okay. Suppose you are visiting outstation and you have booked one hotel. What happen? Whenever you are going to book the hotel, by default, what happen? The booking site you can see where all the rooms are vacant, right?
Yes.
All rooms are vacant. Which all rooms are vacant. And what are the different prices of that particular room? Everything information you are going to get on website. But let's say a traditional method. Suppose you have booked one room. To whom you need to contact? You need to contact one manager, right?
Yes.
You never ever go to contact the staff. Definitely contact the manager of the hotel. Okay. Any respective person is there. Book the hotel. Manager does not know. He never ever understand how many people are going to stay. Or sorry, manager has only is going to give you the information. All the rooms are vacant. Okay. Not going to say you stay in this room and if it is filled, he is not going to tell you I will vacate this room and if you will come I will let you I will make the accommodation for you. Okay. If there is any vacant room is there, then he will going to inform you that this room is vacant and we can make your booking. Are you getting my point?
Yes.
So in HDFS file system also same things. All the knowledge about, because HDFS is maintaining the meta information. Meta information means for manager which one is the meta information? Meta information which means what are all the rooms are vacant. Room number is the meta information. Room number, suppose 500 is vacant in 5th floor. That is the meta information. But within this room, where all the things are available, he is not responsible. For that, have already kept the staff, right? Staff is responsible whether the room is cleaned or not, the bathroom is good or not, the bed has properly decorated or not. Everything is it is the responsibility of the staff. But manager only keep the meta information. Meta information means whether the all the accommodation has been done properly or not, all the required things are placed well placed or not in the room as per the customer needs, the decoration has been done or not. Okay, all these things in all these things to his hand only. Okay, he knows all the information, but the meta information only. He not going to clean your bathroom. You are not going to clean the food for the hotel room. Okay, we are going to stay in this hotel. Getting my point?
Yes.
So likewise, HDFS system, master node is only responsible because he has all the idea.
Yeah. Actually, the master node only represent the. It will take all the information of the metadata for each node. Right. Then the actual data, how is 9 point only.
That is we are going to see in the backup in the block size and backup mechanism. Then we come to know whenever a client machine is going to send a file request. Okay. Suppose
One question is there. Suppose this is my master node is there. So master node will be decided. It will go to the. It will create the horizontal scaling. Correct.
horizontal scaling, it is not going to create the horizontal scaling.